Hi, my name is Shashank Indukuri and today I am going to record this video for Milestone1 of SE456. Now I am going to run the application, and as per the initial requirement I have set the full screen resolution as well as shapes and proportionalities for all the aliens of total 55 aliens, and by using the animation command and move command, and those are added to the TimerEventManager, and the images are automatically swapped as well as they are moving with a discrete steps horizontally from front to back. And coming to the next requirement, so I'm going to cover all these patterns. My first one is the Singleton. So for the Singleton I'm going to open the sprite box UML diagram, and here we can see the sprite box manager is inherited from the base manager, and all the sprite boxes are owned by the sprite box manager. So when I open the sprite box manager, we can see there is a static method, which means it's a global instance and we can able to access this instance anywhere in our program. So when I go back to game.cs, here I'm creating this instance by just using the class name itself. To actually see the sprite boxes, so I'm going to uncomment this. I am going to comment this piece of code, and when I save and run, here I have added the boxes for each and every sprites on the screen, and we can see all these boxes are added to the different sprite batch. So when I toggle off these sprite boxes, I can simply toggle remove the sprite batch from the game, and we can not able to see the boxes. And coming to the next pattern, which is factory. So here in the game object alien, so I have created this alien factory which takes the input, and based on the input, here it creates the different kind of aliens. So in the game.cs, so I have created the alien factory, and by using this instance I am creating different kind of aliens. And coming to the third pattern, which is object pooling, for this I'm going to open the ImageManager. So basically this ImageManager, it will create instances and reuses them when necessary. So to demonstrate this pattern, so I'm going to uncomment this piece of code, and I'm going to run the application. For this demo, I am removing the crabs images from the image manager and replacing them with the red bird and green bird. So currently we can able to see the crabs, but after a few seconds the crabs are automatically replaced by the red bird and green bird. So when we observe the output here, so initially when we remove them, so there are 5 active and 2 of them are moved to reserve list because we removed 2 crabs. And when we are adding the red bird and green bird, it is utilizing the reserved list and added back to the active list. So this demonstrates the object pooling. And when going to the priority queue, so for this I'm going to open the TimerEventManager. So basically when you are adding timer events to the TimerEventManager, it inserts based on the delta time. So it is basically calling this base add to friend in the base manager, and based on the priority I am invoking this add node on priority, which is part of double link manager. So in this method add on priority, based on the float priority, I am adding the timer events which has the highest priority to that. And coming to the next pattern, which is proxy, basically here we are utilizing the single original sprite and making the copies based on the original sprite. So for this I'm going to open the sprite proxy. So it's basically here it links to the original proxy where we can see here, but by just updating the x and y values and calling this update and render, so we are creating the proxies or copies for the original sprite. So when I open the sprite proxy UML diagram, we can see that there is a sprite proxy manager and there is a sprite proxies, and each sprite proxy is linked to the actual original sprite. And when coming to the command pattern, so here the movement of alien grids from the timer command. So for this I'm going to open the game.cs. So for this movement and animation I used two commands. So one is the animation command, and I have created each animation command for each type of alien, squid, crab and octopus, and for the movement I have created another move command, and all these commands are added to the timer event manager. So and based on the time set to that, all the commands will be executed. So for the example I'm going to open the animation command. So in the animation command, so it is inheriting from the base command, and by using overriding this execute command, execute method, it will performs its operation based on the time to trigger that is handled by the timer event manager. So when coming to the next pattern, which is iterator, for this I'm going to open the sprite batch manager. So in the draw method, so here by using the instance of the sprite batch manager and getting the iterator from the base manager, and it has its own method, so we are iterating over the double link list and performing and drawing each sprite batch from it. So to even more demonstrate, I'm going to open this double link iterator. So it has its own the methods that is overridden from the base iterator, and it retrieves the first node, current node, the next node, so it iterates over the list. And when coming to the template pattern, I'm going to open the sprite manager. So in the sprite manager, when you are adding sprites to the manager, so we are utilizing this base. So let me just open the UML diagram for the sprite batch. Sprites. So as similar to that, the sprite manager is inherited from the base manager. So let me open the base manager. So here when you create the manager, it calls this base manager and it creates some reserved nodes from it. So here it is using the derived constructor node, which is implemented in the subclasses, which is a template pattern. So we are utilizing actually by using this method, we are restricting the subclasses to implement this, and by making the template for it. And when coming to the next pattern, which is composite pattern, so the composite pattern is it's a kind of a tree-like structure where we are implementing all the aliens in a grid hierarchy. So the composite is inherited from the component, that is the base abstract class, and there is leaf and the composite, and composite is nothing but it has multiple childs, and leaf doesn't have any child to that. To demonstrate this, I'm going to open the game.cs, and here I have created this alien grid, which is nothing but a composite, and the alien column that has an hierarchical, and for each column I am adding a bunch of aliens to them. So and finally I am adding all the columns, each column, to the alien grid, which is highest composite. So by using that, so it will iterate over the tree, and it is showing all the aliens and they are moving within a hierarchy. And next pattern is a null object pattern. So the null objects are nothing but if there is nothing else present to that object, we will be using null objects. So to demonstrate this, I'm going to open the game object alien grid. So basically this is a composite, and for this alien grid there is no actual sprite proxies that is linked to it, because this is just the hierarchical highest hierarchy. So to fill the sprite proxies, so we are using this null sprite proxy, which is just the placeholder for that. So in the composite pattern itself, so each squid or anything, it is actually linked to the sprite proxy. So the each game object is linked to the sprite proxy, and as the alien grid or alien columns doesn't have the actual proxies pointing to, so that we'll be replacing with that null object. And coming to the last pattern, which is adapter pattern. So adapter is nothing but it acts as an adapter, and it takes some input and converts into another input that is supported format. So for this adapter pattern, I'm going to use the texture. So basically we have created this texture class, which is an adapter. So it adds up some values from the client, and it is actually linked to the Azure texture, which is the Azure framework. So this is acting as an adapter. So to demonstrate with, there is an UML diagram. I'm going to open it. As we can see, there is a texture manager, and this is a texture. So it is pointing out to the Azure texture, which is the main texture. So it reads the input from different format, and it is converting into another format in the texture class. So this is the final pattern, and for the internal code, I have labeled all the news with LTNs and STNs appropriately in all the files, and that's it. So thank you so much.